Hello everyone, welcome to all. Myself Dr. S. Indrani, Department of Electronics and Instrumentation Engineering, SRM Institute of Science and Technology. Today topics Introduction to the course on Automotive Sensor and Subsystems. Under the Automotive Sensor, the module on Safety and Security System. Under the safety and security, the topic is tire pressure monitoring system. A tire pressure monitoring systems is a crucial safety features in modern vehicles. It continuously monitors the air pressure inside the tires and alerts the driver when the pressure falls below a certain threshold. This helps prevent the potential safety hazards such as blows, decreased fuel efficiency and uneven tire wear. There are two types of tire pressure monitoring system, direct TPMS, indirect DPMS. Direct tire pressure monitoring systems, it uses a pressure sensor located in each tire, provides a real-time pressure readings. Sensors are typically mounted on the tire's valve, stem or inside the tire. Indirect tire pressure monitoring system use the vehicle's anti-locking braking systems, wheel speed sensors. Infers the pressure loss from differences in the wheel rotation speed. Does not provide actual pressure readings but detects significant changes. This is a block diagram for the tire pressure monitoring system. The important components of the tire pressure monitoring system: pressure sensor, transmitter, receiver, warning indicator. The function of the pressure sensor measures the actual air pressure in the tire, include the temperature sensor to compensate for temperature variations. The function of transmitter sends the pressure data from the sensor to the vehicle's onboard computer. The function of the receiver receives the data from the tire sensors. It is often integrated with the vehicle's electronic control unit. The function of the warning indicator located on the dashboard alerts the driver when the tire pressure is low. That function of the tire pressure monitoring system, the step is first one is initialization. The system is calibrated with the recommended tire pressure values. Monitoring continuously monitors the tire pressure while the vehicle is in motion condition. Alerting activates a warning light on the dashboard if the pressure drops below a preset level, indicating the need for the maintenance. Safety reduces the risk of the tire blows and accidents. Fuel efficiency maintains the optimal tire pressure, leading a better fuel economy. Tire longevity prevents uneven tire wear, extending tire life. Environmental impact reduces the carbon dioxide emission by maintaining the proper tire pressure. Challenges: sensor maintenance, battery life, cost. The sensor maintenance means sensor can fail and require periodic maintenance or replacement. Battery life: sensor is typically have built-in batteries that last several years but eventually need replacement. Cost: the direct TPMS can be more expensive to install and maintain compared to the indirect TPMS. The overall tire pressure monitoring system is an essential feature for anti-locking braking systems. Anti-locking braking system is a safety system in vehicle that prevents the wheel from looking up during braking. This helps maintain a traction with the load surfaces, allowing the driver to maintain the steering control and avoid skidding. Here is how it works and why it is beneficial. How anti-locking braking system works: wheel speed sensors. Each wheel is equipped with a speed sensor that monitors the speed at which the wheel is rotating. The next control module, this is a brain of the APS. It receives the data from the wheel speed sensor and determines whether any wheel is about to look up. This diagram for anti-locking braking system, hydraulic pump and valves and wheel speed sensor is available. How the anti-lock braking system, about the hydraulic valves. The valves control the brake pressure applied to each wheel. When the control module detects the potential lockup, it modulates the brake pressure via these valves. Next one is pump. The pump is used to restore the pressure to the hydraulic brakes after the valve have released it. This allows the system to APS. The next one is deduction. The wheel speed sensor continuously monitor the wheel speed. Analysis. The control module analyze the data to detect if a wheel is decelerating too rapidly, indicating a lockup. This action. The hydraulic valve reduces the brake pressure on affected wheel to prevent the lockup. Reapplication. Once the risk of lockup is reduced, the system reapplies the brake pressure. Benefits of the anti-locking braking systems: improved steering control. APS allows the driver to maintain the control of the vehicle while braking, which is especially important in emergency situations. The next is shorter stopping distance. On many surfaces, APS can reduce the stopping distance compared to the conventional brakes. Next is reducing the skidding. By preventing the wheel lockup, APS reduces the risk of skidding. Next, enhanced safety on slippery surfaces. APS is particularly effective on wet and icy or loose surfaces where traditional brakes might lock up more easily. Different type of ABCs, anti-locking braking system. That is one is 4-channel 4-sensor APS. Each wheel has its own sensor and valve providing the most control. If any wheel is about to lock, the system can modulate the pressure to that wheel individually. 3-channel 3-sensor APS typically found on pickups with 4 wheels. Each front wheel has a sensor and there is one sensor for both rear wheels. Maintenance and consideration. Regular checks. ABS should be regularly maintained to ensure the sensor and components are functioning correctly. APS warning light. If the APS warning light comes on, it indicates the problem with the system that should be checked by a professional. Driving with APS. While APS improves the braking safety, drivers should still maintain the safe distance and drive according to the road distance. Maintenance and consideration. APS is a crucial advancement in vehicle safety technology, helping to prevent the accident and improve overall vehicle control during braking. Next one is traction control systems. Traction control systems are a part of a vehicle's electronic stability control system that helps to prevent the wheel slip during acceleration. This is a diagram for the traction control system. How the traction control system works, that in sensor monitoring wheel speed, a traction control system relies on sensor that monitor the speed on each wheel. The sensors are typically the same ones used by the anti-locking braking system. Detecting the wheel slip. The system continuously compares the speed of each wheel. If it detects that one or more wheels are spinning faster than the others, indicating loss of traction, it activates the traction control systems. Next, reducing the engine power. Traction control system can momentarily reduce the engine power to the slipping wheels. How traction control system works, that by applying brakes. The system can also apply the brake to the slipping wheels to slow them down and help them regain traction. Benefits of the traction control systems: improved stability, enhanced safety, better acceleration. Improved stability means by preventing the wheel spin, DCS enhance the vehicle's stability, especially on slippery surfaces like wet or icy roads. Enhanced safety, it reduces the risk of skidding and helps maintain the control of the vehicle, thereby increasing the overall safety. Better acceleration, DCS ensures the smoother and more efficient acceleration, particularly at uneven or low creep places. Increased tire longevity, by preventing excessive wheel spin, DCS can help reduce the tire wear and extend the life of your tires. The limitation of the traction control systems: reduce the performance in certain conditions. In some off-road or deep snow situation, traction control system might reduce the vehicle's ability to power through the difficult terrain. Many vehicles allow the driver to disable the traction control system in such scenarios. Dependence on anti-locking braking system. Since traction control system uses the same sensor as the APS, any malfunction in the APS can affect the DCS functionality. Next topic is electronic power sharing system. An electronic power sharing system in a car, also known as power distribution or management system, is designed to efficiently allocate the electrical power to various subsystems and components in the vehicle. Here is an overview of the key aspects of the electronic power sharing system. This is a diagram for the power sharing distribution system. The components of the power sharing system: battery management system, power distribution unit, inverter, converter. Battery management systems monitors and manage the car's battery, ensuring it operates within safe limits. Distributes power distribution unit distributes the power from the main battery to various electronic components. Inverter and converter functions: converter DC power from the battery to the AC power for certain component and adjust the voltage levels. Next important component is the control unit. The function of the control unit include the engine control unit, transmission control unit, and other that they manage specific vehicle functions. The function of the power distribution unit is, the first one is load management. The load management is priorities power distribution based on the vehicle's current needs and available power. Next is energy recovery. Recovers energy from the braking and other sources to recharge the battery. Next, thermal management. Thermal management maintains the optimal operating temperature for the battery and other components. Diagnostic monitoring continuously monitor the power systems. Next, the benefits: improved efficiency, optimize the power usage, reducing energy waste, extended battery life. Proper management and distribution of power help prolong and battery's lifespan. Enhanced performance ensure that the crucial system receives the power they need for optimal performance. Safety prevents overloading and short circuit, reducing the risk and electrical failures. Thank you.